All right, everyone, glad you could make it. For today's paper, we're looking at something I know is a shared pain point for basically everyone in this room. We've all been there, right? You're deep in Overleaf, and you're stuck in that endless, soul-crushing loop of copy-pasting between your editor and some LLM in another tab. It completely kills your flow. Well, this paper tackles that problem head-on. It's called PaperDebugger, a plugin-based multi-agent system for in-editor academic writing, review, and editing. So here's the game plan. We'll start by digging into what the authors call the broken writing workflow. Then we'll look at their solution, PaperDebugger, and really get into the nuts and bolts of its architecture. The really interesting part comes next. We'll look at their real-world analytics to see if people are actually using this thing. And finally, we'll see it in action with a couple of demos. Okay, so first things first. Let's frame the problem that's motivating all of this work. The core issue they identify is just how fragmented everything is right now. We have these incredibly powerful language models, but they live over there in a separate tab, totally disconnected from where we do the actual work. In Overleaf or whatever editor you prefer. And this fragmentation leads to some really frustrating problems. You're constantly context switching, doing that copy-paste dance, which just shatters your concentration. But I think the deeper problem, the one that's really critical for us as researchers, is the loss of provenance. The moment you close that chatbot tab, the entire reasoning process, the why behind a suggestion, is just gone. It vanishes into the ether. So to tackle this, the authors propose PaperDebugger. The idea is, frankly, what we've all been waiting for. Bring the AI agent directly into our primary writing environment, and in this case, they're targeting Overleaf. So what is it exactly? Well, at its heart, PaperDebugger is an in-editor, multi-agent assistant. And those two words, in-editor, are the key. It's all about embedding that LLM-driven reasoning directly where you're writing, so you never have to leave your document. The paper frames its contributions in three main areas. First, obviously, is the in-editor experience that gets rid of that painful workflow. Second is a pretty robust, scalable architecture. They're using Kubernetes to orchestrate these different agents, which is a smart choice for handling complex parallel tasks. But third, and for me this is what makes the paper really compelling, is that this isn't just a prototype. This is a real tool live on the Chrome Web Store, and they have the user data to prove that it works and that people want it. All right, so let's pop the hood and take a look at how this system is actually put together, from the high-level architecture down to the individual agents doing the work. They've designed it with a pretty clean 5-layer architecture. You've got the presentation layer, which is the Chrome extension you interact with. That talks to a backend written in Go running on Kubernetes. Then you get to the really interesting part, the agent layer, which has these different containerized agents. And it's all held together by a protocol layer using gRPC and server-sent events, with an infrastructure layer at the bottom. This diagram here gives you a really nice view of the whole process. So you're in Overleaf, you highlight some text, you make a request. That hits their main server, which basically acts as a traffic controller. It looks at your request and routes it to the correct specialized agent, the reviewer, the researcher, and so on. That agent does its thing, and boom, the result is streamed right back to your editor. And this idea of specialized agents is really at the core of their design. Instead of relying on one giant monolithic LLM to do everything, they built a team of experts. You've got a reviewer agent that acts like a peer reviewer, an enhancer for rewriting, and even a researcher agent that can go out and do literature searches for you, which is pretty amazing. We'll see that in a bit. Okay, so the system design looks solid, but the million-dollar question for any tool like this is, are people actually using it? Is it just a cool idea, or does it have real-world traction? Let's dive into their adoption data. So first off, the install number is pretty solid. They have over 4,000 installs from the Chrome store. That alone tells you there's a real hunger for a solution to this problem. But of course, installs can be a vanity metric, right? What we really care about is engagement. And this is where it gets impressive. They're seeing over 700 monthly active users. So people aren't just trying it once and ditching it. They're coming back and making it a part of their regular workflow. And this table gives us the whole story. You can see the installs and active users, but look deeper. Over 3,000 projects created, nearly 7,500 interaction threads. That's a lot of engagement. That points to real, sustained use. And that user rating, a 4.82 out of 5 is nothing to sneeze at. People clearly like this thing. Now, this chart, I think, is one of the most revealing pieces of data in the whole paper. Look at the most frequent action. It's not generate text, it's diff viewed. That tells us people are using this as a collaborator. They're asking for suggestions, carefully reviewing the changes as a diff, and then deciding whether to accept them. This is an iterative, human-in-the-loop process, not just blind acceptance. All right, theory and data are great, but let's actually see how this feels in practice. The authors walk through 2 core workflows that really show off the system's capabilities. So here's the first one, basic in-editor editing. Imagine you've written a title for your paper. You just highlight it, pop open the PaperDebugger panel, and ask it for a critique. The agent goes to work and comes back with suggestions, presented as these really clean before and after diffs. You can see exactly what it wants to change, and if you like it, you just click to apply the patch. It's this beautiful, tight feedback loop, all inside the editor. Okay, but now for the really powerful stuff. Let's say you're working on your related work section. Always a joy, I know. Instead of just asking for a grammar check, you can highlight a whole chunk of it and ask the agent to perform deep research. This is where the tool goes from being a simple writing assistant to a genuine research partner. And look at this. The system goes out, does a semantic search across academic databases, and comes back with a ranked list of relevant papers. And it's not just a list of titles, you get abstracts and, crucially, an LLM-generated summary explaining why each paper is relevant to what you wrote. And it's fast. They say it found these 7 papers in about 11 seconds. But this is the real game changer. After finding those papers, you can ask for a direct comparison. The researcher agent then reads both your draft and the other paper, and it generates this incredible side-by-side table comparing the goals, methods, and limitations of each. It even gives you takeaways to help you better position your own work. I mean, this is far beyond proofreading. This is high-level conceptual assistance. So ultimately, what we're seeing here is a fundamental shift. Tools like PaperDebugger are transforming the editor from just a passive place where we type words into an active agentic partner. It becomes a collaborator that can help us not just write, but think. And that, of course, leaves us with a really big question to chew on. As these in-editor agents get more and more powerful, moving from grammar checkers to research collaborators, how do we, as a community, start to redefine authorship? Where does the human's contribution end and the AI's begin? It's a tricky, fascinating problem, and I think we're going to be talking about it for a long, long time. Anyway, that's the paper. I'd love to open it up for discussion. What are your thoughts?